Hello everyone, welcome to this session on AWS Networking. And what we are going to do today in next 30-35 minutes is we are going to touch base upon a few of the important constructs around networking when we think about or when we talk about AWS. And there are a lot of things which are generic to cloud computing, but we are going to focus around important components that makes AWS what AWS is, in terms of security and scale. So we will also go through few of the hands-ons. I'll try to show you a few of the things in the console, but I'll strongly recommend you that based on your interest area, or if you want to dive deep into few of the topics that we are going to touch base upon, you should explore the AWS documentation, as a lot of things changes as we speak. So always refer to the latest documentation from AWS. Okay, so if you are new to Reskill, I've been recording few of the sessions for Reskill. My name is Suman Devnath. I work with the developer relations team, and I'm based out of Bangalore, India. And I predominantly focus around things around storage, serverless, and machine learning. So if you have any questions or queries regarding any of these content that I'm going to present, please feel free to send me a message, or you can reach out to me over LinkedIn or Twitter, whichever you feel like. Okay, I'll be very much happy to help you. With that being said, let's get started. So when you think about networking in general, the first thing that we can think of is, let's say, internet, because at the end of the day, we are talking about cloud, and we all access that from our respective place or data center or home, right? So it's all, everything is on the internet. So let's assume that this is our internet, and this is the AWS premise. So this is basically let's say you have created an AWS account, and you are inside this, right? Once you have logged in, you are inside this shell. Now in that, what you do is you may create several resources, like Amazon EC2 instance, maybe the virtual machine service that we have, or you might create an RDS instance for your database workload, or even you can create an EMR cluster for data analysis and analytics. And similarly, you can have many different services. It doesn't matter what it is, but the idea here is, once you create an AWS account, you create resources within your account. Now these resources doesn't get created in the vacuum. So all these resources gets created within something called Amazon Virtual Private Cloud, or VPC. So this is the outermost shell that you get, which segregates or which isolates you from any other network. So basically, this is your own virtual private cloud, which you can use to create or deploy your application. Now, when you create an AWS account, you will get a default VPC in all the regions. And this default VPC offers you something, right? So default VPC comes with CIDR range, like this is the default address 172.31.0.0/16, and we are going to deep dive into this particular IP address, and we will see what this address or CIDR block eventually means. Okay, but when you create an AWS account within your region, any region you may pick, you will get one default VPC, and this would be the CIDR range for the VPC. And if you notice here, all the resources that you have created all are in this IP range. So if you see, the CIDR is 172.31.0.0. So all these instances that you see here all are in the same IP range, right? So that is one thing when you create a default VPC, when you get a default VPC. Now, to manage these IPs, what we do is we create small subnets. So if you if you are aware of the whole AWS global infrastructure, we have regions, and within that region we have availability zones, so or AZs. So what are availability zones or AZs? AZs are basically an isolated place or within a region where you have it can have one or more data centers which are completely different from different power domain, completely different the network provider and all of that. So that the reason that we have multiple AZs within a region is to reduce the effect of any outage. So it might so happen that there is a flood or some electric outage in a particular region, a particular city, and it should not affect your workload or your data. So what happens is when you create a VPC, the default VPC will have some CIDR range, and then within this whole range of IPs, we create smaller subnets. So you can create one or more subnets within an AZ, but a subnet can belong to only one AZ, one and only AZ. Okay, so you need to keep that in mind. So now in this example, if you see these two instances are in the same subnet, and that's why the IP, if you read the IP address, it's quite evident that they are from the same subnet. Whereas in this one, 31.1, and this is also 31.1, this belongs to a different subnet, right? So these subset of IP addresses which are there in subnet 1 or subnet 2, they all come from this CIDR range of your whole VPC, right, which is 172.31.0.0. You also get an internet gateway, and we are going to talk about what internet gateway is in a bit. But basically, if any of the resource within your VPC would like to access the internet, then you need to have an internet gateway. Okay, so that is also you get with the default VPC. And then we have security groups and NACL, and I'm not going to touch base on that at this point because we are going to talk about what security group and NACL are in the following slides. So now that we got a holistic idea about a VPC and how we get how our default VPC looks like, and what are the subnets and the CIDR range that we get. Now let's jump into a few of the core concepts and fundamentals of VPC. We will start off with the IP addressing, that is how the address looks like, and how we create subnets, and this is the most important thing, how we route data packet within the VPC. And not only that, we will also look into how data goes within your VPC to from your VPC to outside world, right? And finally, we will talk about security. So let's start with IP. So when you create your custom VPC, not the default one, when you create your custom VPC, it is very important that you define your IP address properly, because your CIDR range will define how many private IP you will get, right? So let's go back to our previous example of this IP, which is the IP of the default VPC, 172.31.0.0/16. So this is not a random IP address. This IP address is taken from the RFC 1918. So there are many different ranges like this which are mentioned in this RFC. You may like to explore this whenever your time permits in the internet. But basically this is a private IP, and what that says is this IP you will not find in the internet. So you can easily use this within your private VPC, so there won't be any IP clash. All right, so there are many different ranges available which you can use as a private IP, and this is one of them. Now if you look at this IP address, the last two digits or number is 16, and that basically says how many different IP addresses you can get out of it. So this is basically the mask, 16 means the 16 bits from towards the from the end are masked. That means these two defines the network, and these two octet defines the the IP address of the host or instances that which we can use within our VPC. Right. And one important thing to consider is when you are creating your own VPC and defining your address range. One thing is your your CIDR will will dictate how many addresses that you can have within your VPC. Not only that, you need to make sure that you don't use same IPs within multiple VPCs. So when you are getting started, you may create one VPC, and you can pick any random IP which we can take in as a private subnet, as a private IP. But over the period of time, it might so happen that you need to create multiple VPCs, and instances or resources within one VPC need to talk to instances and resources in the other VPC. So in that case, if you have not taken all of these into consideration, like selecting the right IP addresses, you might get into situations where you will have conflicting IPs. That means same IPs might exist in two VPCs, and they cannot communicate, right? So this is kind of a fundamental of networking. Always keep this in mind, that you should always avoid overlapping of IPs. Okay. All right. So next, let's move on to how we can create subnet. We discussed about subnet a bit a while back, where we said that you can have one or more subnets within an availability zone, and the subnets are not highly available by within itself, because one subnet can belong to only one AZ. But what you can do is you can create multiple subnets across multiple AZs within a region and deploy your application. Now, let's go back to our example. You have a VPC, we have a CIDR range for our VPC, and let's assume that we have three availability zones, like EU West 1A, 1B, 1C. Now, three availability zone, we can have three subnets, right? We can always have more than one subnet within an AZ, but let's assume that we have one subnet in every AZ. And each of these subnet will get an IP CIDR from the VPC. So if you see, all of these IP ranges like 1.0, 0.0, 1.0 and 2.1, all are the slice of this main VPC CIDR. Right, so this is /16 IP address, and these all are slice /24 IP address. Right, so that's why it is very important to consider what is the starting range of IP that you are starting off with. So since this is a /16 IP address, we can get 65,000 IP addresses, right? So which is good enough for any organization in today's world, and which is not unusual that people may need more than 65,000 IP addresses, right? The way that we are consuming internet these days. But this is how the IP gets address gets allocated and sliced and diced, starting from the VPC CIDR to these subnet CIDRs. Okay, so that's about VPC. Now, as we all know, I think in this last 1 decade or so, we are in a discussion, not now, I mean from I think from 2008 2009 time frame, we started to think about what would happen once IPv4 address space gets dried up, right? Because we have a finite number of IP addresses, and we have plethora of devices across the world these days, right? With mobile, tablets, so on and so forth. So that's how IPv6 came into existence, and in AWS VPC also supports IPv6, and the way that we support is we support it in a dual stack fashion. And the only difference, one of the difference, there are a lot of different differences that you should keep in mind, but one of the most important a differentiator is that these subnets are of fixed size. So the VPC will have a CIDR range of /64, and all the subnets within that VPC will have a CIDR range of /54 for the VPC CIDR range, and /64 for the subnet CIDR range. And another important thing to keep in mind is all of these IPs, in IPv6 are publicly routable, right? So it's not like IPv4 where you can have a private IP or a public IP, but here all the IPv6 address are publicly routable, right? So that means that it's unique across the globe, right? So you need to keep that in mind. So if we go back to the previous image, since we can have a dual stack, the way that we have implemented IPv6, you can just enable that at the time of creating the VPC, and this is how you get the IPv6 address across all the subnets and the VPC, right? So now we talked about VPC, we talked about subnet, we also touched based upon IP addresses. Now the next important thing is how a packet flows within a VPC, right? So that's what routing is in a VPC. So when you create a VPC, what we have is root tables, right? So, and root tables dictates a certain set of rules, and so what happens is your default, when you create a VPC, it will have a default root table, right? So this is the only thing that you get when you create a VPC, a default root table. And what you can do is you can create and assign your own root table and attach it to different subnets. Okay, so what happens is you create a VPC, then you get a root table, but then if you want to edit that, you can always create a different root table and attach it to different subnets. So this is how it looks like. So let's say this is one of the subnet, and you create a root table, and in this root table you say that if the destination is this, which is the whole IP range of the VPC CIDR, it says that your traffic stays within your VPC, and the other IP is just for IPv6. So you can ignore that if you are not using IPv6. But basically, if you look at this root table, it says that any instance within your VPC can talk to any other instance within your VPC. But if you look at this table, it is very clear that any instance within your VPC cannot access internet, right? Because there is no address. Let's say if you take an address of 8.8.8.8, that doesn't come under this destination, right? So because that is not the CIDR range that IP address come under, right? So we will see how you can have the internet connectivity for your root table next. But before that, I'll just exit out from here. I would like to show you that. So let's say if I go to VPC, and if I click on VPC here and click on create a VPC, I can give a name, and I can give some CIDR range, and here we can define whether we want IPv6 or not, right? So as we discussed, we can just select IPv6 CIDR block, and AWS will automatically assign you, give you the IP address. You will not have the liberty to select that, and all the IP addresses are publicly routable, as we mentioned. So let's go ahead with no IPv6 and create this VPC. Now, when you create this VPC, you will see that there is a route table attached to that. There is nothing else. There is no subnet. You have to create your own subnet. Nothing, gets created. Now, if you click on this route table, you will see that there is a route table, and if you click on routes, you will see that there is only one destination, which is the IPv6, IPv4, and it's local. So there is no access to internet. If I create any subnet and then create an EC2 instance, and put that into that subnet, and that subnet, if it is within this VPC, it will not be able to access internet, right? So this is something which we are going to see next, that how you can have internet connectivity. Now let's look into this block diagram, and we will touch base on few of the very important concepts, like how you can have internet access from a private subnet or a public subnet. Now there are two terms here, or two different types of subnets. One is public, another is private. We have not talked about what is public and private, but for now, just assume that any subnet which doesn't have the internet access can be called as a private subnet, and any subnet which can have an internet access can be called as a public subnet. Okay, and how we can enable that access, that is something we are going to discuss now. But let's assume that this is your VPC, and we have two availability zones, and within this availability zone we are creating two subnets, one private subnet and one public subnet in each of the AZs. Okay, so this is your VPC. Now, before we jump into the internet part, it's worth mentioning that when you are within AWS, right? So if you see this is the AWS region. Not all the resources stays within your VPC. So there are a lot of resources which we have within AWS, which has a public facing address space, right? So services like S3 or DynamoDB or Lambda, etc. They all, when you use them, when you create an S3 bucket or when you create an DynamoDB instance, they do not stay within your VPC. Okay, so they stay within AWS obviously, but they have a public facing address. So when we create any resources within when you create any resources within your public subnet or private subnet, you need to make sure that they are able to access not only the internet but also all of these services which are public facing services within AWS. Okay, so let's come back to our main question, how we can access internet. So assume that these are the four instances that we have. Instance A, B, C, and D all are in different four different subnets. So as we have learned, every subnet will have a route table, and by default the route table will have a target as local. That means any instance can talk to any other instance within that VPC. Similarly, a private subnet instance in the private subnet or the private subnet will also have a route table which will have the same entry, right? So now how we can access, how this instance A or instance C can access this internet. So first we will talk about how an instance within a public subnet can access internet, and once we discuss that, then we will learn how instance within a private subnet can access internet. Okay, so what we need is basically an internet gateway. So if we do not have any internet gateway, then we cannot access internet. So it's as simple as that. And the internet gateway sits at the VPC level. That's why it's shown here. And what we do is we just update, once we create this internet gateway, we just update the root table with this entry, like any IP address which is not into this VPC address range. We say that the target should be internet gateway. So if you create this instance, right, instance A, and from this instance A, if you type, let's say, ping 8.8.8.8, that means it is trying to reach out to an internet web page or any instance from the internet. It will go to the internet gateway. Okay, so what internet gateway will do is it will have this tuple between the private IP address, which is this 10.1.0.11, which is mentioned here, and it also needs an public IP, right, because this instance is going to talk to the internet. So all these tuples, or the pair of IPs are managed or rather saved into this internet gateway, because this is internet gateway only can see this mapping, and once that is done, it just flows the traffic through the internet gateway to all the services within AWS, which has a public address space. Not only that, it can also access the internet, right? And one important thing to remember is this: that this address, which is a public address, this is not visible to the instances. So if you log into this instance and type if config or IP -a, you will not get this public IP address. Okay, so everything is taken care by the internet gateway, right? So there is a mapping between the private and the public IP address that it gets, or elastic IP, as you can see here, is by the internet gateway. Okay, so this is how an instance in a public subnet can get access to the internet and also to all the AWS public facing services, right? So that's good, but how about these private subnet instances, like let's say this instance C or instance D, if they want to access the internet? And there are multiple reasons why you might need internet access for instances which are there in the private subnet. And one of the use case is let's say your backend servers, which are not public facing, it needs a patch or an update, all right? So it need to have the internet access. So what you do is you create something called NAT, or network address translator. What you do is you create an instance, EC2 instance, and make it as a NAT instance, and then you add that entry into the route table. As you can see here, just like before, you have internet gateway, but now you have instance B, which is nothing but the NAT instance, right? And then what happens is this NAT instance will take care of flowing the data from your public from your private subnet to the internet, right? So that is how this NAT instances work. So all the traffic goes from here to the NAT, and then NAT talks to the internet gateway, and then from here again in the internet gateway it saves the tuple between the private IP address, which is this of the NAT instance, and the public IP address that it gets or assigns to access, right? So there is no way the traffic knows that this, only NAT knows that, because it that is the job of NAT. It will just translate that address. So but the internet to whom this instance is talking, actually it has no idea about who has sent this information or request, right? So because everything is masked within this NAT instance. Now initially we had NAT instance, and you need to create a NAT instance like this and update the route table with your NAT instance ID. But now what we recommend is to create something called NAT gateway, which is much more scalable and much more easy to manage and create. So if you want to get into the details, the difference between NAT gateway and NAT instance, you can look into our documentation. But you should just remember that you should use a NAT gateway, and this NAT gateway need to be always in the public subnet, right? And since we have created a NAT gateway, so that means that we have to replace this route table from instance B to NAT gateway. That's all. Okay, so there is nothing much needed, and this is how you give internet access to your public subnet to the internet. Okay, so I mean, how you get give a public internet access to your private subnet. All right, so the next thing that we need to talk about is the security, right? And when we talk about security, there are different constructs or logical entities that we have. One is security group, another is NACL, and flow logs. So let's start with the security group. So assume that you have this VPC and you have an internet gateway, as you can see here, and you have the internet, right? And let's say you have 7 instances, and all the 7 instances, you want 4 instances to be instances which are used for a front end or as a maybe an HTTP server or whatever, right? So basically web servers, and the below 3 instances which are marked in blue are, let's say, the backend instances. Now what you can do is you want to group them together with a different entity called security groups. Okay, so here we are naming the security group as my web server, and here we are naming it as my backend. And why we need this? Because we want to have a different set of rules for all these instances, right? And which is quite obvious, because for this my web server security group, you may like to allow all traffics from the internet, which is obvious, and that is how it should be. Since this is a web server, all these instances are web servers or internet facing servers, whereas your backend server need not have to be having the access to the internet, right? Because your backend server should only be talking to your front end or the web servers. So here you can create another security group called my backend, and here you can set a rule for your inbound traffic only from this my web servers. Okay, so basically security group, you can think of it as a virtual distributed firewall. Okay, and it's completely it's not stateless, it's completely stateful. That means if you allow the traffic in one direction, it assumes that the traffic can go to the other direction as well, right? So that's why we call it as a stateful distributed virtual firewall. Now if you see in the console how it looks like, so let's say these are the two security groups we have: my web servers and my backend server. And in the my web server, if you see the inbound rule, you will see you can discard this second line, because assume that you don't have IPv6, so you will have just one entry, and you see that it says that it is open for the whole internet, right? But now when you look at the backend security group, okay, in this case the inbound rule is little different. So in the inbound rule, we have custom TCP, and here we are not defining any address, but we are giving the ID of the security group. And if you read this carefully, if you read the last 3 characters, EB7, and this is EB7, and this is nothing but my web server, right? So you can create security groups, and you can give the source as not only IP addresses but also security group and other resources. Okay, so that's the beauty of security groups. All right, so So we talked about security group, and now we can talk about NACLs or network ACLs. So we are not going to go into deep into NACL because it's a lower level construct, and but we should know what are the basic difference between NACL and security group. So few of the important things to notice is this NACL operates at a subnet level, right? Whereas security group operates at an instance level. So you can create a security group just like we have created, and we have assigned 4 web servers into that security group. So basically, it operates at an instance level, right? Whereas NACL operates at a subnet level. So you can define different NACLs at different subnets. Also, one important thing to notice is or remember is security group allows only supports allow rules. So you cannot say this kind of traffic from this particular node or IP range is not allowed. So you cannot have a deny rule. Whereas in network ACL you can have deny rules. Okay, so that is also important to remember. And the another important thing to remember is we learned that security group are stateful because it returns the traffic automatically. So the return traffic gets allowed automatically, whereas NACL are stateless. That means that you can explicitly there is no explicit allowed. So you have to have an explicit rule set for both the traffics. From A to B and B to A. Right. So there is no auto allow traffic, auto allow rule as we have in the security group. All right, so far we have talked about the security group, we have talked about NACL, and these are all security constructs, but we have not talked about how you can analyze and see what is happening, how the traffic is flowing, right? And this is where flow logs or VPC flow logs comes into picture. So VPC flow log you can create at a VPC level, as you can see here, or you can create it at a subnet level or at an AZ level or a subnet level, whatever you think about. Whatever you you want to map it to, or you can even create it, or enable it at the instance level. So you can have it at instance level, at subnet level, as well as at the VPC level. Okay, and what it does is it monitors the data traffic and it analyzes. So it doesn't read the payload, but it just reads the description. Okay, and once it reads, it need to store that data somewhere, right? So it you can save that data either on S3 or CloudWatch, and you can then may analyze the data using Athena or any of the analytics tool which are saved which is saved in CloudWatch or S3, right? So basically you can use VPC flow logs for troubleshooting or analyzing traffic or a better visibility of what is going on in your VPC. So if you are if you have walked around a few of the networking gears, like let's say I think it was called Wireshark, I guess, if I'm not wrong. Or any of the packet sniffers. So it's basically, it tries to do that, not at a very deep level. You might use a third-party vendor for a product to do a little bit deeper level analysis, but VPC flow log is good enough to start off your troubleshooting or analyze your traffic. So the way that you can create a VPC flow log is you go to the VPC console, and then you can click on this create flow log under this flow log tab, as you can see here. And if you see in this image, you need to also define where it should save the logs, and it could be either on S3 or it could be on CloudWatch, right? So you can select whatever you want. Okay, so before we move on to the next topic, I think it's worth to look into how an entry in the VPC flow log looks like. So it's pretty straightforward. You have the AWS account. That means the account where you have enabled this. So maybe your account. Then you have the interface ID, and then you have the source IP address, and then you have the source port number, and then the destination IP address and the destination port number, and then it says which protocol, and then how much bytes has been sent, what is the time, and accept or reject, right? So it's not very exhaustive. You can read it, so it's quite readable, and all these data are saved in S3 or CloudWatch, whatever you have defined while creating the flow log. But this is how the entry would be into S3 or CloudWatch. All right, one last thing that we should talk about is the DNS. So just when we talk about networking in general, DNS is very, very important, because we as human being cannot remember IP addresses, right? And that's why we at AWS also supports DNS, and this is something that you get with your VPC. And we have two options. One is DNS resolution yes, and another is DNS hostname yes, as you can see here. So what this allows you to do is it allows you to resolve your instance IP addresses to the host names, and also it will give you, whenever you create any EC2 instance or anything, you will get a DNS host name automatically assigned to you, so that you don't have to remember the IP address, and you can just use the DNS name. Okay. All right. So we talked about VPC. We talked about what are the different components that we have within the VPC, and how the IP ranges are designed, and how subnet gets the different set of IP addresses. And we also talked about security constructs, few of the security constructs, flow logs, etc. So whatever we have discussed so far is all within the VPC. Now, how about connecting to your VPC? So that means, let's say you have multiple VPCs, how those VPCs can talk to each other. Not only that, if you have an on-premise data center, how your VPC can talk to on-premise network. So these are the two topics that we want to discuss now. Now let's start with connecting to other VPCs, and there are different ways that you can connect to other VPCs. We have two such products or services rather. One is VPC peering, and another is transit gateway. So let's start off with VPC peering. So let's say you have a VPC A, B, C, and D. So let's say these are the 4 different VPCs that you have, and all are in different address range. So there is no overlapping of address, as you can see here: 10.3, 10.1, 10.0, and 10.2. Right? So there is no overlap. So now let's say you want to have a connection between VPC A and D, and you want to have another connection between C and B. Right? So if you want to do that, what you do is you actually create 2 VPC peering between these respective VPCs. Now, you might have guessed it by now. If you want to have more connectivity between, let's say, VPC A and B, and C and D, you need to have a different VPC peering. So more and more VPC you have in your environment, and more your need is to connect to each other, you need to create a different pair of VPCs. So VPCs are private IP connectivity between 2 VPCs, as we can see here, and we can have cross regions, so it can be in different regions, and we have to make sure that CIDR ranges must not overlap. That is one of the most important thing. Now, you can imagine that this might get a little complex when you have more number of VPCs, and that is where transit gateway comes into rescue. But before we look into the other options that you may like to choose, if you have a lot of VPCs in your environment, let's see how VPC peering can be set up. So it's very straightforward. It's just like how what TCP handshaking happens. So you have two VPCs, one in the left hand side, one in the right hand side. What you do is, let's say VPC one, which is on the left hand side, that is the pink VPC, starts or initiates an peering request. Then the blue VPC accepts that request, and then what you do is you just update the route tables in the respective VPCs. So let's see how the route table would look like for this VPC. So if you see, this VPC need to talk to this VPC, all right? So this IP range is 10.55.0.0, and that's why you have an entry of 10.55.0.0/16. But now in the target you have this VPC tiering construct, right? So similarly you will have an entry in this route table, which is part of this VPC, blue VPC, right? In that case, this IP address would be this address, right? And there will be different VPC construct. This is a randomly generated string. It will be a different. It will be the same, not the difference. I'm sorry. It's the same. VPC peering construct. Okay, so that's how you can establish VPC peering across two different VPCs. Now, if you have more than two VPCs, we have seen that how it would look like, right? So now we will talk about transit gateways. So transit gateways will not only ease most of our efforts that we have seen to connect between different VPCs, but not only that, it can also help us to ease the infrastructure when we think about communicating with outside AWS, maybe on-premise or somewhere else. So let's say you have, so this is again before transit gateway, you have two VPCs, you will have a VPC peering between them. Let's say you have more VPCs, again you will have more peering, and so on and so forth. Now let's say you want to, you already have an on-premise data center. So what you will do is, if you want to connect that to your AWS VPC, you need to have a customer gateway, and then you will have something called a VPN connection, right? And then if you want to connect it to different VPCs, you again need to have different VPN connectivity. So as you can see, all of these are different VPN connectivity connecting to different VPCs in this diagram. So it's quite complex, but this is how it is when you start off connecting any on-premise infrastructure to your AWS account, right? Or to your AWS VPC. Similarly, there are different ways that you can connect your on-premise infrastructure to your VPC, and the other one is using AWS Direct Connect Gateway. And in that case also, if you want to connect your on-premise data center, you need to have the connectivity with AWS VPC. Now this looks very cluttered. There are a lot of things, moving things here, and that's where with VPC, transit gateway comes into play. So here we will have two VPCs as before, but now what we can do is we can just create a transit gateway, and this can talk to both the VPCs. Similarly, if you add more VPCs in your infrastructure, you don't have to create a different VPC peering. All you have to do is you have to just point it to this transit gateway. Similarly, for on-premise, you can use again the VPC connection, and the customer gateway would remain as it is, but now it doesn't have to have a different connectivity with different VPCs. It can just talk to the transit gateway, and it will route the traffic across all different VPCs as it may be needed, right? So similarly with direct connect, right? So basically all that mess that was created because of VPC peering goes away because of this transit gateway. Okay, so you may ask when to use VPC peering then, right, if transit gateway is so good. So it depends how many VPCs that you have. So VPC peering has a different limit of 125, and don't take these numbers by heart. I think few of the numbers might change as we speak, but look out for the documentation for the right number at the time that you are planning to implement or explore this, right? But basically, one of the important thing is the VPC limit. You know how many VPCs you can connect with. All right. So the last thing that is that we would like to talk about is how you connect your VPC to your on-premise infrastructure. So let's say you have your VPC in the right hand side, and left hand side you have your on-premise data center. So there are two ways that you can connect. One is AWS VPN, and another is AWS Direct Connect. So we have just talked about this at a high level, but let's see how this thing works. So let's start with the AWS VPN connectivity. So the first thing that you do is you create a customer gateway, right? So that is at your on-premise side, and this could be any networking device. It could be a gateway, or it could be a router, or it could be a firewall, or whatever, right? So yeah, so that is in your on-premise side. And then you need to have a virtual private gateway, right? And this should be within your I'm sorry, this should be in the side of your VPC. And then you create a VPC tunnel, VPN connectivity, and this creates a two IPsec tunnels. Now, why two IPsec tunnels? And this is because we create two separate VPN termination endpoint in two different availability zone for high availability. Right, so this is very important. We are creating this because of high availability, so that we get two different endpoints, right? And if you are not using any protocol like BGP, you need to add that in the route, right? So this is BGP is one of the protocol that is supported by VPC. So if you are not using any dynamic routing protocol like BGP, you need to add that into your routing table. Now that's about VPN connectivity. Let's see the other option, how you can connect your AWS account with your on-premise infrastructure or on-premise data center using Direct Connect. So again, this is on the right hand side, you have the AWS, your VPC, your virtual private gateway, all remains the same, and this is your customer network or your on-premise data center. Again, everything remains the same, but now we have something called Direct Connect locations. So you can check our website where all we have these locations, but basically these are the places where we have lots of networking gear, routers and all of that. And what you can do is you can just connect your data center which is nearest to this Direct Connect locations, and connect your data center to these ports available in our routers. So it's basically a direct connectivity from your data center to AWS, right? And once that is done, you need to have a private virtual interface on your data center, and it can now talk to the virtual private gateway, and then it can talk to other resources within your VPC, as you can see here. Not only this, AWS Direct Connect also helps you to have access to all the resources within AWS which are public facing, right, which has an public facing address space. So in this case, like we have discussed about this, right, like S3 or DynamoDB and so on, right? So this is very, very important, like Direct Connect in and mostly into enterprise customers, because not always you would like to have an internet connectivity, or basically you don't want your data to flow through internet. So you have your on-premise, you have resources on AWS, and you don't want the traffic to flow through the internet, right? So you want to have a dedicated connection to your VPC. So this is one of the way that you can do so. Okay, so I hope you got an intuition about what are the different resources that we have when we think about VPC. What are the different components? We have not gone through everything, like we have not touched base on a few of the things like VPC sharing or VPC endpoint or interface endpoint and so on. But you can always do your own research and share with me if you have any queries. But I just wanted to give you a high level overview of few of the networking constructs that we have within AWS. Okay, so if you get some time, please attend the quiz and feel free to ping me on LinkedIn or Twitter, wherever you feel like. And if you have any questions, I would be more than happy to help you. Okay, with that, I'll see you soon in some other sessions at Reskill. Thank you so much for your time. Have a good day.